flip-flop inputs ang SR, ang JK, ang D, ug ang E. Okay. So, mao na atong nabuhat last semester sa kaning part na human. So in our previous example last semester, I guess we solved this one manually. So given this given this logic diagram, we tried to implement the circuit. So for this circuit, we can convert it into the state table. Once we have the state table, we can now we can now draw the state diagram. So first, sa ito itong unang gibuhat aning dapita so that we can come up with the state table. We derive the flip-flop input equation. So gikuha nato ang dA. Sa kaning dA ug ang kaning dB. Kani sa? So once we have the dA and the dB, we also need to get the y, kaning output nga y. So in here we would say dA is equivalent to x times A plus x times B. Ito ang dA. And then your dB is equivalent to x times A prime. And then your y is equivalent to A plus B times x prime. Thus, we would be able to get now the state equations, and then after the state equation, we try to plot the state table. Ano nga table atong i-plot? Once makuha na ang table, we can now get the state diagram. Inumdum pa? Inumdum pa nga part? Diyon sa pagkuha? Inumdum ra? Silence means yes ha? Sige. So once you have the state table, you can now convert it into the equivalent state diagram. So if you already have the state diagram, okay, we now try to implement using behavioral modeling in Verilab. Okay? So we will try to create our module. Let me just try to adjust. Okay? Let me create a new file. And then also, we take note that in here, in this circuit, we take note that our inputs would be the X and the X ra ang atong input X ang input niya, ang atong output kay Y. Another input would be the clock and the reset. So this is our module. We can say this is our module. So this is MDL. We'll say this is MDL1. Let's say MDL1. For MDL1, our inputs are X and X. Then we have our output Y. And then we also have our we have our reset R. And our clock also C. So inside, we have present states. Inside in here, we have what we call as present state variable. And we also need to have our next state variable. NS. Okay? So with this, we will try to generate the output Y given input X and the corresponding reset and clock input. So also take note sana at present state of next state inside our module 1. Any concerns or questions and clarifications? Wala. So since wala, let's now proceed to creating the code. So we'll name the code as MDL1, our module number 1. So we say module MDL1, whose inputs are X, clock, and reset. So might be we can say X, Y. Take note our Y is the output. Save this one as MDL1.b. Okay, so we say N module. Then inside of which we will try to set the inputs. So we say input X, clock, and reset. And then we have our output Y. Then we also try to take note that this Y output will be assigned using, so ito itong assignment. Itong, sige. And then inside, we need the present state and the next state. So for which the present state and the next state are 2-bit values. So we have our present state, so we need to create a register. That's 1 down to 0 for the present state and the next state. Or you can say PS and NS. And then we will try to create constants. For this case, we can say this is constant S0. This is our S1. S2, and this is our S3. So meaning our S0 is 00, our S1 is 01, our S2 is 10, and our S3 is 11. So we try to create parameters, okay, for which we will try to assign S0 is equivalent to 2-bit value, 00. And then we can create also S1, which is a 2-bit value, 01. and then S2 is equivalent to 2-bit value 10, and S3 is equivalent to 2-bit value 11. So once we have our parameter, we will also try to create the circuits, create the values of our clock and our reset. So we would try to say always at, so we would say at the, kami atong clock, ada saka sa clock mo function siya. So always at, mo reset siya sa always at the positive edge, post edge of our clock, or kada naog sa atong reset, negative edge, neg edge of our reset, meaning mo, check ta sa, so if ang reset, so if not reset, then we will try to set our present state, go back to state 0. If reset gani, kay ang reset na to, padungman ubos, di ba? Kung ang reset na to kay negative or 0, reset siya. So ang atong reset, by the way, is active low. So take note, this is an active low, active low reset. So meaning, ma-reset ang atong circuit if the reset is equal to 0. Else, if the reset is not equal to 0, then the present state value will be equal to the next state value. Okay. Another instance, this is the computation of the clock and reset basing on the next state value. So we try to assign it into the present state. And then also, checking on the values of the next state. So how to check the values of the next state? Checking of the values of the next state. How to check the values of the next state? So we try to create the values of the next state basing on the value of the y. Or if there are changes on the present state. So we would say always at if there are changes on the present state or a change on the value of the input x. So you can use or. You can also use katong or nga operator. Hindi mo na siya stricto. So case, so we will try to switch the value of the present state. If the present state is at 0, 0, so we would say in here S0. So if the present state is equal to 0, 0, we will try to check the value of x. If x is equal to 1, then we proceed to state 1. That is, we would say if x is 1 or if x, then we would say next state is equal to S1. Else, what happens is that the next state is equal to S0. It remains at S0. Kanisa, kung nata sa state 0, yung input 0, the next state value is 0. And then also S1, when the value of the present state is S1, we check the value of x. If x, kasama na siya pa doon, then we would say next state is equal to S3. Else, next state is equal to S0. Nakapas? Please confirm, nakapas? Nakapas ra guys? Panaan nga to, hindi akong estudyante ay. Panaan may mo tingog. Sige, padayon na. Next, S2. That is at state 2. If the value of the present state is state 2. So that is, so kanasa always at a change of the present state or a change on the value of x kung usab na siya. We look into the value of the present state. So if the present state is S2 and we check the value of x, if x is 1, then we would say next state is equal to S2. Pabilin na ta sa? Kani kung ang input nato ay 1, pabilin ta. Else, we would say next state is equal to S0. And then lastly, S3. So if x, so if the value of x at S3 is 1, then we would say, just like to copy some parts. Okay? So the next state is, kasama na siya S2. Else, next state is 0. Nasa balik. So that would be the checking of the value of the next state based on the corresponding value of x and the present state. So we say in here, end case. That is to end the switch statement, kaning case nga statements. Another checking would be also on the value of the output. So basing on the value of the output, so we would say checking the values of the output. Okay. So we would again always check the value of the present state if there are changes, or on the value of x. And then we would want to case the value of the present state. Okay? So if the value of the present state is equal to S0, then we will now check again the X. If X, then we would assign the value of Y. So the value of Y, if the input is 1, kari. So if the value of X is 1, the output is Y. So we will just try to say Y is equal to a 1 bit 0, or you can 0. And then you can say else. Natay mo join. Okay. Join si Roger. Else, if the value of X is 0, kanina part. That is, we would say Y is equal to a 1 bit 0 output. And then, next state 1. Join. Okay. So next, if the value is at state 1, if present state is equal to state 1, we check the value of X. If X is 1, Y equal to 0. If X equals to 0, Y equals to 1. Next, state 2. At state 2, if the value of X is equal to 1, the output is 0. Then, else, if it is 0, then the output is 1. Kana sa kani. And then, last state 3, we would have if X is equal to 1, Y or output is equal to 0. If X is equal to 0, output is equal to 1. So that ends the case statement for the checking of the end case. For the checking of the values. If you want, you can also combine this one into one always at statement. Ana, imo i-combine din natin. Isa na lang sa. So after we have our module, MDL1, so the next one is to create our simulator. So we say MDL1 simulator. Okay? So we need to generate value of X, R, and C. So we also need to have registers for X, R, and C. And then we need to connect. So that is the module that we are going to create next. So we have our MDL1 simulator. So for this case, we can say module MDL1 simulator. So for this simulator, the ports are X, clock, and reset. So we would have in here output X, and then also the clock and the reset. So for which we will try to create also registers for X, clock, and reset. And then also we will say initial, begin, end. So this will now have our values. So we will try to say dump file. And then also we will say MDL1.BCD. Small m lang, small letter sa batang andan. And then we would dump bars. Okay. And then after which, we would try to set our clock to 0 at start. Clock is equal to 0. And then we can assign values of X and value of reset. So might be we can say reset is equal also to 0. Okay. And then we can now change the value of 1. Sorry, the value of X. So might be we can say X equal to 0. And then probably a delay of 3. Then X equals to 1, a delay of 3. So X equals to 1 might be another set of delay. X equal to, and then, then we can also set the reset to 1. Meaning, if set na to sa reset to 1, mo-function na siya. So once the reset is set to 1, we can now just try to assign values of X again. So depending siguro kung mong gusto, 1, 1, 1. You can say 0, you can say 1. Then you can copy so that you can have a transition. And then lastly, our finished output. If not also sa kaning atong clock, we need to have a clock that is of a continuous square wave signal. So we need to generate a clock signal. So we say always at, no changes. So always begin, begin, and, okay. And then every 1 clock cycle, so meaning always gina siya i-perform sa walay corresponding na tanawon. So always, every 1 clock cycle i-perform ni siya. So that is, we would say clock is equivalent to not clock, or you can say negative clock. So that ends now the module the signal for the clock, and also our MDL1 simulator. Once we have the MDL1 simulator, we can now create the module 1 test bench. Okay. So in our test bench, we have to instantiate So we say MDL1, M1, X, Y, clock, and reset. Then MDL1 test bench, X, clock, and reset. Wala na yung Y ang atong test bench. And then we will also try to connect them using X, a wire of X, Y, clock, and reset. Okay, so once we have our code now for this diagram, we can now convert it into the equivalent. We can compile it now. Okay, so we say in here, ivory log minus O, MD1, MDL1 dot B, and then DVP MD1, DTK wave, MDL1 dot BCD. Okay. So this is our module 1 simulator. So in here, we take note of values that we had. Okay. So let's try to look into, wala lagi Y. Kasi kuwang, anong wala yung Y?
Sa test bench mo, sir, kayo nabutang. Simulator. Hindi naman test bench.
Ay, test bench. Simulator. Y is not declared. Kaning Y. So we need to set a register for Y. Okay. Hindi ba? Kaya? Hindi. Then VVP, MD1, DTQ wave. Okay. Let's check. This is our test bench. So we now have our X. Oops. Naguna na itong diagram. So we have our X, our Y, our clock, and our reset. So notice that our clock is always changing at, mausap na siya sa, always changing at 1 clock pulse. So di na, ang clock, pag sugod diri 0, after 1 clock pulse, on himong 1. Sa a delay of 1, ma-0 na po siya. So notice ana niya. So also take note that our X initially was 0. Sa tatong code. Itong X was initially a 0, then a delay of 3, matong na 1, a delay of 3, 1, a delay of 3, 0. So mo na ang value sa atong X. Now we try to look into the value of our Y. Ang atong Y, diri ra di ay ni Saka. Diri ra di ay ni Saka. If you want to look into the values of the present state and the next state, you can also add them. Nara, usap-usap ang values of present state of next state. Nara. Mao na siyang value sa present state of next state sa. During the beta, ang ato manggong kani bitaw ang reset up to 12 seconds. Ang ato manggong reset kay kuan 0. So matong wala pa na mo function atong circuit, ang atong present state always 0. Tanawa sa always 0 kay ang ato ang clock, ang atong reset 0. Pag set nato ang reset to 1, matong mo function na. Kani man na siya. Kani nga part. So kung naka-reset siya, ang present state will be at always 0. Pero kung wala na siya na reset, so the present state is equal to the value of the next state on the next clock cycle. Try. Nawa ang atong kuan diri present state. 0 pa atong present state diri sa 0 pa. Ang atong next state kay naka 1 na. Pero wala pa dayon siya ni Saka. Ang atong present state ni Saka siya sa sunod pa nga clock pulse. Nga naman, ang gitan-aw nato ang value sa positive edge sa clock or negative edge sa reset. So during the pita kani siya, wala pa ni siya ni Saka kaya ang atong clock wala pa mo Saka. So diri napita ni Saka atong clock. So diri pa pud na-copy ang value sa atong next state padung sa present state. Nawa, atong present state 0-1. Atong next state kay 1-1 na. Dili pa pud na siya na 1-1 ang present state sa wala dayon siya na 1-1 ang present state kay napaabot pa man ta sa rising edge sa atong clock. So pag padung Saka na sa atong clock o dina na siya na-copy ang value sa imong next state padung sa imong present state. Diri pod 1-0 na ang next state, pero ang atong present state 1-1. Gipaabot niya padung Saka sa atong clock. Kay sa atong code, always at man to kanina part. Always at the positive edge of the clock. So padung Saka nga clock. Tama na siya. So after which also, diri dapita, na 0, 0 na siya diri ang next state because of the value of the x. Ang x din na 0. So nga naman di ay 0, nga na 0 na siya. At 1, 0, if your input is 1, the next state is 0, 0. Tinuod ba na? At 1, 0, if the input is, dili dapita kani. If the input is 0, at 1, 0, nara. Kaning dapita sa at 1, 0, kani 1, 0. If the input is 0, tara. If the input is 0, it goes to 0, 0. Mo na ang next state na himo 0, 0. Okay? Sabtan? So dinhi na pod sunod clock cycle sa ang value sa imong present state na 0 kay padung sa ka ang clock, imong next state 0, 0 na copy. Okay? Dinhi nata sa 0, 0 ang atong input kay 0, so pabilin na siya. Diri ang atong input 0, dinhi nata 0, 0, yang atong input 1. So 0, 0 kanisa 0, 0, yang atong input kay 1, so nisud siya diri sa next state 0, 1. Mana ang atong present, sorry, ano man ni? 0, 1 data sa tara. Nata sa 0, 1, nata sa 0, 1, ang input nato kay 1, so na pud siya sa 1, 1. Okay? So that is the sequence of the present state and next state values given the corresponding values of x and y. So in addition, you can also just combine these parts. Sa kani combine mo din pwede po na siya. Okay? Questions, concerns on the code? Wala. By next Saturday, murag wala ko kay biyahe ko. Next Saturday ha. Pero Monday until Thursday, murag naa pa ko. Friday, murag Thursday sa gabi or Friday sa buntag ang biyahe. Sige. So, on the next example, probably we have solved also this one. So, given a JK flip-flop, we can combine, we can compute for the, or we can create that state table and also the corresponding state diagram. So, once you have the state diagram, you can also create the same code. So, ang inyong usbon ani, would only be this part naman siguro, kanina nga part. Also on the name of the module. So you can say module number 2 and then change these values. So if x, during the pita, if x, ay wala output di isa. Wala tay output, so wala ni siya. So you can just copy, save this one, save as. Name this one as module number 2. Okay, this is now module number 2, module number 2, module number 2. Then this is module number 2, module number 2, module number 2. Take note sa wala tay output nga y, x ra nga tang input. And then also wala tay y dali. Okay? So wala pa din y. For module number 2. So the same concerns na agya po na ang clock o ang reset na ang computation sa present state of next state, checking of the present state values, checking of the values of the output, wala ni kay wala man tay values sa output. Okay? So kana ra siya atong usbon din ng dapita for the next example. So in here, if x is 1, then the next state is 0. Else, the next state is state 1. At state 1, kanisa state 1. Kanina yung state 2 sa so if x at state 1